We're going to discuss now biodiversity and land use and the role of engineers. We are going to review first we were going to reaffirm that what we have learned on these lessons, that biodiversity provides ecological services and aesthetic and cultural benefits. And also it provides other benefits that are more indirect. And these benefits can actually be quantified because they have also an economic value. Human life depends in general of ecological services provided by these organisms. For instance, we know trees moderate our climate, and plants in healthy ecosystems capture water, build soil, and turn sunlight into ingredients. The things that we were talking about, material and energy balances. We have learned now that biodiversity can be affected by changes that are human induced and also natural changes. And the consequences of changing biodiversity include the changes of ecosystem functions that are important for humanity. The large ecological and societal consequences of changing biodiversity should be minimized to preserve options for future solutions to global environmental problems. So, in this figure, we have it has been compiled all the general consequences of changing biodiversity. So global changes include or are grouped all together on the changes related to biogeochemical cycles. That is the relationship between elevated CO2 emissions and other greenhouse gases, what we call global climate change, nutrient loading, and water consumption. And then we also have land use on global changes, species invasions, and also biodiversity is also grouped on those global changes because there can be some changes on the richness, the evenness, the compositions, and the interactions, right? And we know that we all benefit from this biodiversity, and we also have grouped these benefits as economic benefits and cultural, intellectual, aesthetic, and spiritual benefits. These are all together are grouped as ecosystem goods and services. And these are driven by processes in ecosystems. So now we're going to start thinking, or we're going to start discussing, how can we protect biodiversity? There are many ways that can be used to protect biodiversity. And it's not only to not doing or not touching the ecosystems. It is about thinking, about using our engineering tools as well. So one example of protecting biodiversity in the agricultural space is the way of croplands are being produced. So we have here three scenarios where we have natural ecosystems, and then how intensive croplands look in terms of crop production, water quality regulation, water flow regulation, carbon sequestration, and some other key parameters. And then we have a cropland with restored ecosystem services. So here you can see when we quantify these aspects that I'm mentioning to you, we can see how the impacts are less strong if we have if we avoid, for instance, the use of monocultures, and we also allow the introduction or the growth of native species, for instance. So the star that is at the top shows the increase or decrease of these impacts that we're talking about. And we can see, for instance, that intensive cropland is really is really bad for biodiversity. So we also have to ask ourselves, why do you need this information as engineer? The natural ecosystems and biodiversity upon which we all depend are at risk, requiring active protection and rehabilitation. And it requires really the collaboration or the application of different multidisciplinary tools that engineers also can provide. So engineering leadership and multidisciplinary problem solving is crucial to achieving the necessary step change toward a sustainable society. And this has been recognized by Engineers Australia. Although it has been more focused on climate change, it also mentions the importance of conserving or maintaining biodiversity. We know that this is very important because of the characteristics of Australia being very unique in terms of the number of endemic species and that then also the ones that are threatened. But let's think about what can we do to do this, to achieve this. So do we have to protect a species, and how can we protect it? If we have to do some if we are involved in engineering projects, how can we help to avoid or how can we help conservation? How can we help to conservation? The role of engineers in protecting the environment or biodiversity and sustainability includes the resilience of our built and natural environment in the face of extreme weather. So, what is climate adaptation? The need to reduce emissions related to our buildings, vehicles and infrastructure, climate mitigation, and biodiversity protection and enhancement. And this is in line with the UN Sustainable Development Goals. In the aim of protecting biodiversity, engineers in Ireland have developed a very recent document from 2021 where they have identified key issues where they can actually contribute to protect biodiversity. And these are the points. These issues were identified by making a consultation process where different stakeholders were involved, including engineers and other members of society. So the first point is that biodiversity is an opportunity, not a constraint. So when you are working in your, when you will be working in your engineering profession, you will face a perception that if you need to protect biodiversity, it will stop development. And this way of thinking has to be changed. And there is a need to move beyond aiming for no net loss. To biodiversity in engineering projects, to aiming for a net biodiversity gain, which means how can we increase or improve biodiversity. So the design should set out from the beginning to ensure net biodiversity gain, or at the very minimum to ensure no net loss of biodiversity. This can be done by incorporating engineering approaches that can allow for spaces that can have habitats for plants, animals, and for exchange of materials and energy. The second statement is that we need to change what and how we design. So ecologists are often bought in once the design has been relatively fixed. So they ask for input of these specialists on biodiversity too late. It is important to collaborate with other experts at the beginning of projects. So the projects are also in line with sustainability approaches. Aside of changing how we design, we also need to think what we design. Engineers need to have a better understanding of nature-based solutions and learn to apply this. In coastal and river areas, hard engineering works can no longer be considered appropriate, and there is a need to work with nature to ensure positive outcomes. This is particularly important given the changes in weather patterns as a result of climate change, right? The third point is monitoring and accountability, so meeting our obligations. A common theme in the input received through consultations and surveys was that many engineers do not have sufficient knowledge of the requirements related to protecting the environment. So that's why the information that we're providing you here is very important. In terms of monitoring and accountability, the major issue is that if environmental destruction happens in an engineering project, it has happened and often cannot be meaningfully corrected, and there are very limited repercussions. Let's say illegal quarries and other implications, right, that they should be considered. Habitat loss and fragmentation is one of the most important aspects to take care of when engineering projects are happening. But there are some other problems related, for instance, to invasive species. And this is a common problem among engineering projects because there is introduction of species to an environment through different ways. So the question here is now, how can we improve or protect biodiversity? I'm showing you some examples, and I'm pretty sure that there are more and also some Australia related. But I have reviewed this document that it was focused on protecting biodiversity and the role of engineers. And these are very nice examples. The first one is Room for the River, and is from the government of the Netherlands. The main goal of this program was to manage higher water levels in rivers by lowering the levels of floodplains, creating water buffers, relocating levees, increasing the depth of side channels, and the construction of flood bypasses. The program consisted of over 30 projects, and all were completed at the end of 2018. The benefits of these actions include the areas of space to improve biodiversity, and also to improve environmental quality of the river region. The following example is about green bridges. These are very important for allowing animals to cross and to interact in different environments, and that to avoid accidents, right? It also, in this case, this is a bridge that was built for aiming for bat conservation in Ireland and for bat roots restoration. Finally, the last example that I'm showing you, and is very common everywhere, is living walls. This is the one at Trinity College in Dublin, and it also, thanks to these walls, it has boosted biodiversity, and also it has provided habitat for nature. Flowering plants provide pollen and attract a range of pollinators, including bees and other insects. A living wall holds 96 plants per square meter, with species including the following ones. I'm not going to mention the names. So there are a lot of things that we can do to protect the environment. So to sum up, engineers play an important role in shaping the world around us, and it is critical that environmental considerations and achieving the best for society are always at the center of our profession and the work of engineers. And this is a nice statement by Dr. Mike Ryan from the World Health Organization that says we need a world that is more sustainable, where profit is not put before communities, and where the slavery to economic growth is taken out of the equation. We need sustainable growth in our communities, and we need sustainable livelihoods for our people. And we're taking huge risk, massive risk, with our future if we don't manage the planet in which we live. And we're being extremely responsible right now.